Okay, so now we're going to just analyze some of the basics from algebra. Make sure that you understand some of the most important basic terms that we're going to use throughout this class. And so let's start with an expression. So what is an expression? Well, it turns out an expression is really just a way of saying something, right? So it's a way of saying something in English or whatever language you speak, right? It's a way of saying something. So what's an algebraic expression? So an algebraic expression is, again, it's simply the way we have of saying something in the language of algebra. Okay? In the language of algebra. So there's something I never knew that I'm going to just tell you right now. The difference between what we call an expression, and I didn't know this until I got to college, and I should have figured it out, and you probably are smarter than me and already know this, but I didn't really realize the difference between an expression and an equation. So an equation involves that there's an equal sign somewhere in it. Expressions right now we're talking about, they don't necessarily have any kind of equal sign in it. So let's look at a very, very basic expression. So here we have x plus 2. So as we talked about before, what we see here is that we have a variable, and x is our variable. Now, does it have to be x? Of course not. Does it have to even be a letter? No. This can be a variable. It can be a symbol, right, of any sort. You could say, hey, that's my variable I'm going to use, and it represents something. So the key is that, the variable represents something. And when we say something, we don't mean like a person or like, something that can't be, we don't mean like, I don't know. What we mean by something is that it represents a value, a quantity, okay? So some measure of something, okay? And then, of course, we have here is an operator. We talked about that before. It's representing the operation. And here we have the constant, right? And now we're going to take a look at what happens. So this is right here, the basic expression, and it is in arithmetic. What about, in algebra, and it involves these three pieces here. So then what about this one here? So this is an expression also. But this expression, there's nothing between the 2 and the x. So I always say when nothing comes between two people, right, they ought to get married, right? I guess when they're basically living together, that's traditionally what happens anyway, is that people get married. So I think of this as a marriage situation. And so that reminds me, the M for marriage reminds me that the operation is implied multiply. So multiply is what's going on here. So now, when two things are being multiplied together, really we're saying that it's just two sets of x, right? So this represents, what does this represent? This represents x plus x, right? Because multiplication is really just repeated addition. And so this tells me there's two sets of x, so I have x plus x, right? And if I had 25x, that would be x plus x plus x plus x 25 times. So I'd have 25 sets of x, right? So this is actually just considered one value that's put together in 25 ways, but we can consider this a single value, and this is called a term. Okay, it's a single term. Now this is also a term, and this is also a term. So these are terms. Okay, so now we have a term, just like the constant was a term and the variable was a term, but we have a value in front of our variable and it's still a term. Now that value here, we know it's a constant, but it's not, we know that 2 is defined, and so in this case 2 is a constant, right? But over here it's 2 of something, and it's not, this term is not defined. So now the 2 is giving it's serving a different role or a different purpose. It's not telling us the quantity 2 on its own. It's telling us 2 of something, right? And so in this case, it's called a coefficient. It is not out there on its own. It's like these two people together. They are cohabitating. They are living together. These two things. So it's its coefficient. Okay, that is the coefficient. Okay, now let's talk about another way that you will see terms look. Here's another form that you'll see a term in, and that is in the form of an exponent, right? This guy right here is the exponent, right? But altogether, this is one term that we would use in an expression, a single term in an expression. And the 2 in this case is not telling us how many times x is being added, it's telling us how many times x is being multiplied. So when the 2 goes in front, it's just a count of how many times it's been added. And when the 2 goes up here into the superscript, what we call the superscript, it's telling us how many times it's being multiplied, okay? But because the values, they have x sets of x terms, boy, I can't even draw that out. I can't even represent that, right? If I had 2 to the second power, or 2 squared, right, that would mean that I had 2 sets, right, of 2 items. So that's 2 rows, 2 columns, 2 rows, and 2 columns. That's why we call it a square, 2 squared, right? Because we have 2 rows, 2 columns, so it's 2 squared, okay? And if I had 2 to the third power, it would mean I'd take these 2 rows and I would have, well, what does it mean? Does it mean 2 times 3? Does it mean I have 2 sets of 3? No. It means I take my 2 squared, right, and I multiply it by 2 again. So this means 2 times 2 times 2. So it means I have my 2 squared, and then I have 2 sets of 2 sets of 2. So here's one set of 2 sets of 2, and then a second set would need to be made that represents 2 sets of 2. Oh my gosh, it grows pretty quick, doesn't it? So 2 cubed is not 6, because it's not 2 times 3, right? So we don't just add in a third here. It says 2 sets of what? 2 sets of 2. So here I had 1, 2, right? 1, 2, and there's my first set, or here's my first set of 2, and there's my second set of 2, however you want to look at it, okay? And, now I have a second set of 2 sets of 2. So the exponent just tells us how many sets of something we have. And as you can tell, that's going to grow really quickly, because if I had 2 more, then I would have to draw 2, I'd have to double this again. And so quickly we go from, instead of 4 or 8, we'd have 16. And if I added another 2, then I'd have to go all the way to 32, and it would just start growing crazy like that. Okay, so let's look at the expression one more time. Here's a little more complex expression. I have an expression that looks like this: 5 plus negative 2x, well, we'll say plus 2. Now this expression consists of how many terms? Well, this is a term, and this together, these two are a term, and this is a term. So there are 3 terms, right? So when there's 3 terms, we call this a trinomial, okay? When we have just 2 terms, so let's say I had simplified this a little bit. So what we do with terms is we try to simplify them, make them smaller if possible. And the way we do that is we find terms that are alike and we combine them. So here I have 5, and there I have 2, and it's all being added together, and those 2 terms are alike, so I can add them. So that becomes 7 plus negative 2x. And now that I have simplified, this is called a binomial. But the important thing is that we understand that these 2 terms are exactly the same quantity. They're just different form. And this is what's really, really, really important about algebra. We can have the same values, the same quantities expressed in different ways. There's freedom of expression in algebra. You can express things in different ways, okay? So that's an important thing to kind of figure out here. And if I had only a single term, if I took away the 7 here, I only had negative 2x, that would be called a monomial. And if I had 4 terms, that would be called a quad. No, it's not. No, it's not a quadnomial. It would be we just call them, as soon as they get to 3 or more, we just call these polynomials. Polynomials means many. This is tri means 3, bi means 2, mono or mo means one. It's the root for one. The nom comes from the same Latin root that nombre in Spanish, which means name. And so if you had three different things, they all had the same, they would each have their own name. You might think of it that way, that there are three terms that are named in this expression, right? That's really kind of the background of where that comes from, that polynomial. So this means many names in my expression, right? Or many terms in my expression. A couple other little things I've got to show you real quick. We have to talk about factoring just a little bit. Now, sometimes in my expressions, like here's a binomial, in my expression I see a common factor, and in this case 3 is a prime number, but I know that I can write 3 times 1, and that's the same thing as 3. And so I can do that for both of these terms. So now I have an expression where there is a common factor in every term in the expression. It's only a binomial. There's only 2 terms. See, we count them by how many have been added together. So it's only a binomial, but the first binomial has a factor of 3, and the second binomial has a factor of 3. And so one of the things we do in algebra is that we remove the factor. We remove the factor. And now we just have the factor on the outside of the expression. Okay? So this we call factoring. Now you might remember, probably in pre-algebra, they introduced you the concept of distribution, where we take a factor on the outside and we distribute it in. I know I've heard talk that in some of the schools here in Burley, they say, jump the fence. They jump the fence and fill, each of these terms gets the 3 distributed to it. So it's not 3 just times x. It's 3 times the whole thing, x plus 1, and we would distribute. So distribution is the act of multiplying a factor into a group, right? And factoring is the process of taking a common factor out of the group. So factoring and distribution. And those things are pretty important to know. And I think that really that about covers what we need to do today, right now. So that's where I'm going to stop.